This is the quiz review for Unit 1B. Which of the following rules expresses the transformation? So notice you have A, B, C, D, E, and then you have A prime, B prime, C prime, D prime, E prime. And the best way to do these is to pick a point to experiment with. And make sure you don't pick one that has a 0 in it, because 0 isn't positive or negative. So let's do E, which is 1, 4. And make sure you go in the right order. E would go to E prime, and E prime is at -4, 1. So if you notice, they have switched places. So we want to make sure we pick an answer that has Y and then X. So we can mark out A and B. And if you notice, the Y value became negative. It's the opposite. And your X value stayed the same. So opposite Y, X would be the rule to represent this transformation. A regular pentagon has rotational symmetry. What is the minimum number of degrees a regular pentagon must be rotated about its center in order to prove this? Whenever you're talking about rotations, you're going to use 360. That makes a full rotation, and you're going to divide. In this case, you're talking about a pentagon. A pentagon has 5 sides, and 360 divided by 5 is 72. Remember, you can pause this video, rewind it, and listen to whatever you need to again. Number 3, what is the reflection across the x-axis of the point A4, 1? Let's go ahead and pause for a minute and review our rules. For reflections, if you're reflecting over the x-axis, you do the opposite y. If you're reflecting over the y-axis, you do the opposite x, and y stays the same. If you're reflecting over the line y equals x, then they switch places. And if you are reflecting over the line y equals -x, it's going to be opposite y, opposite x. So those are the rules for reflections. Remember, for translations, you're just moving up, down, left, or right. So for a translation, you add to the x if you're moving to the right. You subtract from the x coordinate if you're moving to the left. You add to the y coordinate if you're moving up. And you subtract from the y coordinate if you're moving down. And then for rotations, the way I remember those is I always draw a coordinate grid. And then I start by doing this. I write x, y, x, y. And then in these quadrants, I write y, x, y, x. And in this quadrant, positive x, positive y. But in this quadrant, your first coordinate is negative and then a positive. So I put a negative sign right there. This quadrant is negative, negative. And this quadrant is positive for your first coordinate and negative for your second. And this is going 90 degrees counterclockwise. This is 90 degrees clockwise. And this is 180 degrees clockwise or counterclockwise. Either way, you use that rule. Okay? And 90 degrees clockwise is the same as 270 counterclockwise, and 90 degrees counterclockwise is the same as 270 clockwise. Okay, so a reflection across the x-axis, we're using the rule x opposite y. So my original point was 4, 1, so that would become 4, -1. So that is my final answer, 4, -1. Number 4, which of the following is a single reflection of the figure n over the y-axis to form n prime? So we want to reflect over the y-axis. Remember, this one's the y. And a reflection is a flip. The only one that flipped over the y-axis was A. Jody has corners for a picture frame. Which transformation could she use to show that corners 1 and 2 are congruent? Congruent means the same. Well, if I fold them and they're the same size, then they are congruent. So I need to fold this so that 1 and 2 will match up. Well, how can I fold that? I need to fold it along line N. So I'm going to reflect it. I'm going to flip it over. I'm going to fold it over. So it's a reflection across line N. Figure E, F, G, H on the coordinate plane has vertices -5, 2, -5, -2, -1, -2, and -1, 2. If the figure is translated 5 units to the right and 2 units up, what are the new coordinates? Okay, so 5 units to the right, we're going to add 5 to the x. 2 units up, we're going to add 2 to the y. So let's start with point E. That is at 1, 2, 3, 4, 5, -5, 2. And we're going to add 5 to the x. That would put me at 0, and add 2 to that one. So that would give me 0, 4. So 0, 4, the only one that has that is A. So I didn't even have to do all the coordinates. Number 7, 3 transformations will be performed on triangle ABC. Which set of transformations will always produce a congruent triangle? So an exact same size. Dilation changes the size. It either makes it smaller or bigger, so it's not going to be congruent. So you cannot have dilation in your answer. Rotation, translation, and reflection is going to give you a congruent triangle. It'll be a different spot on the coordinate graph, but it'll give you the same size triangle. Coach Nelson is designing a new park that will have both a baseball diamond and a softball diamond. The baseball diamond will have the same dimensions as the softball diamond. A diagram of the park with the placement of the softball diamond is shown below.
All staff, this is a planned fire drill green. Again, this is a planned fire drill green.
The position of the baseball diamond will be determined by a reflection of the image of the softball diamond about the line y equals x. So you're reflecting over y equals x. What are the coordinates of the reflected image of point C? All right, so it's hard to see, but point C is at 3, -9. And remember my rule for y equals x? We said it goes from xy to yx, so you just switch their places. So you get -9, 3 as your answer. Use the graph to answer the question. A dilation of a scale factor of 2 is applied. What are the coordinates of B prime? Well, B is at 1, 2, 3, 4, 4, 2. If you dilate it by 2, you multiply by 2, which gives you 8, 4. So D. Rotate 9 degrees counterclockwise about -5, -2.